All right, good morning, and today we are starting our next module, and we are going to be talking about slope. So hopefully you are familiar with slope. Remember, slope is represented, as it says here, by m, okay, and that's the slope of a non-vertical line. So if you remember vertical lines straight up and down, the slope of a vertical line is actually going to be undefined, okay, if it's straight up and down. It's a one unique case. Otherwise, we represent it by m. To find that slope, it's a ratio. It says the vertical change, also known as our rise, and the horizontal change, also known as our run. So rise over run, I'm sure you've heard this. So the change in y, which is y2 minus y1, over the change in x, x2 minus x1. So you probably want to write this formula down if you're taking notes, if you're not doing it on the computer. Okay. Now it says find the slope of line AB and line CD. So we look over here, and I know it's kind of maybe hard to see because of the darkness of this, but AB right there, if I draw a line through that right there, CD is right here, those two lines. So it doesn't matter which one we do first, I'll just find AB first. So A and B, we are going to need to choose one to be 0.1, one to be 0.2. Okay, so if I choose A to be 0.1, then 6 is x1, 4 is y1, 7 is x2, and 3 is y2. Now remember, for AB, the formula is y2 minus y1, so 3 minus 4 divided by, then it's x2 minus x1, so 7 minus 6. So negative 1 over 1, okay, and that slope is negative 1. Okay, so our slope of AB is negative 1. Now to find the slope of CD, we'll do the same thing. I'll use blue here. So there's our 2 points. If we use this as x1, y1, this is x2, y2, then it's going to be 1 minus 3 all over 3 minus 1. This time we'll get negative 2 over 2, but hopefully you know that reduces to negative 1. So what do we notice about these two slopes? Hopefully you notice they are the same. Okay, and we'll come back to that in a second. My first question, though, is do you think it matters what order we put those points into? And if you're not sure, let's try it. So here we said this was x1, y1, this was x2, y2. What if we had it the other way around? So if we did it the other way around, instead of it being 3 minus 4, it would be 4 minus 3. Instead of 7 minus 6, it'd be 6 minus 7. 4 minus 3 is 1 over 6 minus 7 is negative 1. We still get negative 1, the same slope. So as you can see, the order does not matter. What does matter? Do you see how 7 and 3 are paired up here? They also are paired up here on top of each other. 6 and 4 are paired up. 6 and 4 are paired up there. 3 and 1 and 1 and 3, they have to be paired up with their partner above them. Okay, now, what do we observe about the slopes of parallel lines? I'm hoping you notice they are the same as we said. So this will always be the case. If you have two parallel lines, they will always have the same slope. Or congruent slopes is another way to say that. So it says, what do you predict the outcome would be if we highlighted a third parallel line in the figure and then calculated the slope? Okay, so if I don't even have any points, I just draw this line in here. If it is also parallel, I hope you guys know that that would have a slope of negative 1. So two non-vertical lines are parallel if and only if they have the same slope. We know that is true. So if we look here now at these, it is asking us to find the slope of the given segment. Then we draw a line that is parallel and goes to the y-intercept of 1. So the first step is find our slope, rise over run. So keep in mind it starts here, it goes up 1, 2, 3, and then it's over 1. Okay, so the slope equals 3 over 1. So it has to go through the point 1. Now, the slope is 3 over 1, or you can write the slope is 3. Either one of those is correct. Goes through this point, so up 3, up 1, 2, 3, over 1. Or you could go down 3 and left 1. Either way, and, oops, let me fix that. We will get this line As you can see, they are parallel. They run beside each other, never touching. Now our next one, so you can see down 1 and over 1, 2, 3. So negative 1/3. So we start up here and then down 1 over 1, 2, 3. Or you could go up 1 and left 3. And there we go. They're parallel. We are done. And the final one like this might give you a little trouble. If we think about this, it'd be down 1, 2, 3, 4 over 2. So some of you might want to put that as our slope, and it's right, but it's not as good as we could get. Negative 4 divided by 2, we can reduce that, so it will be negative 2, or down 2 over 1. So if it goes through this point, down 2 over 1, down 2 over 1, or you can think of it as up 2, left 1, and there we go. There's our line that is parallel. All right, so take a look now at this next problem. It asks us to find the slope and decide if they are parallel or not. So in case you forgot, our formula is y2 minus y1 all over x2 minus x1. All right, so our slope here for the first one is NO. And we know that it is going to be y first, so 6 minus 5 all over 4 minus 1. 6 minus 5 is 1. 4 minus 1 is 3. So our slope is 1/3. Now in a different color here in blue, I'll do PQ. So once again, 4 minus 3 will be our slope. That's the y. 5 minus 2. And as you can see, we will get 1 over 3, so 1/3. So if it is 1 over 3 and 1 over 3, are they parallel? Yes. All right, so next, it says write an equation of a line with a y-intercept of negative 3 and a slope of 2. Okay, so y equals mx plus b right here. This m is our slope, and b is our y-intercept. Hopefully you know this slope-intercept form. We've had this before numerous times. Okay, this is our y-intercept. Okay, so y will equal, our slope is 2, so y equals 2x plus negative 3, or I can just put negative 3. All right. Now, sometimes we aren't given the y-intercept. Sometimes we are given a point and a slope. So it says write an equation of a line that passes through the point 3, negative 1, and has a slope of negative 2. So in that case, we will use our formula here, point-slope form. We are given this slope. Okay, we are given this point. Which one comes first? Hopefully you know the 3 is our x, and our negative 1 is our y. So that takes care. We have the slope, we have the x, we have the y. We plug those in. So y minus negative 1 equals, then it's going to be negative 2 times x minus 3. Okay, we'll do y minus negative 1, so we'll get y plus 1 equals, we distribute that in, negative 2x plus 6. Okay, at this point we just subtract 1, and we are left with y equals negative 2x plus 5. Now on the next one, same idea, except now it says write an equation of a line that passes through the point 2, 0 and is parallel to the line y equals 2x minus 1. If it's parallel, hopefully you know the slopes will be the same. So we find what is the slope of this initial line. The slope is just 2. So we'll use that same formula, y minus y1. In this case, y1 is 0. So y minus 0 equals, our slope is 2, and then x minus x1, so x minus 2. Y minus 0 just becomes y. We distribute and get 2x minus 4, and we are done. Now the final one of today, a little bit harder. Once again, we are finding the equation of a line that is parallel to this line. But notice it's not in slope-intercept form. It's in 3x minus y equals 1. Okay, it's standard form. It also goes through this point over here. It says negative 4, 3. Okay, so we know this will be our x1, this will be our y1. But to find our slope, we know it's parallel, so it'll have the same slope with this line if we can figure out what the slope is. So if we have 3x minus y equals 1, we need to get y by itself. Okay, to do this, let's subtract 3x from both sides. Leaves us with negative y equals negative 3x plus 1. Now hopefully you know that negative y is the same as a negative 1. So if we divide by negative 1, it cancels here. We're left with just y. Got to divide each of these by negative 1. So y will equal 3x minus 1. The slope there, as you can see, is 3. So if it is parallel, it will have that exact same slope. It will have 3. Okay, we go back up here. So this is the formula we're using. So I'll do this in red now. Y minus our y1, which we said was 3, equals whatever the slope is, which down here on the right we said is 3, times x minus x1 is negative 4. So y minus 3 equals 3x. Now remember right here, if it's minus minus, that's the same as plus 4. So 3 times 4 is 12. We're almost done. All we got to do then, add 3, y would equal 3x plus 15. And we are done. So I hope you guys have a great day. There is no assignment today. Tomorrow there will be a Delta Math assignment. And then Monday we're going to do a computer review. So that information will be in It's Learning. Hope you guys have a great day, and I'll talk to you later.